This is something we've been doing for a few years now. This conference really mixes academic and industry perspectives, and that's kind of mixed into a lot of the different parts of the conference. But we think there's some things that often come up in more the practical industry setting or other organizations using experimentation that maybe don't have a place elsewhere in the conference. So we have a practitioners panel to try to bring out some of those themes. My sense is that we get to touch on things that wouldn't really be being discussed in the program otherwise. They're discussed in the hallways, et cetera, but aren't discussed otherwise. So we have a really excellent set of panelists with us today. So we have Brent Cohn from Stripe. We have Guillaume Saint-Jacques from Roblox. We have Bilal Zia from Duolingo and Tulle from Lyft. And I think as the conversation goes, we'll get to hear a little bit more about some of the perspectives and experiences they have from both where they are now and also from a lot of the different roles that they've been in previously. So just to kick things off, I think a lot of people, maybe not here, but a lot of people think when they think A/B tests, they think, okay, we use the A/B test, we make a decision, that's it. But my sense is that people are using data from experiments for other purposes, using them in other ways downstream, reusing them or running the experiment for a totally different purpose to start with. How else are you using data from experiments in your organization? Brent?
Sure, yeah, happy to go first since I'm most proximal here. So for context at Stripe, my team owns a product that effectively tries to optimize three things for our customers: their authorization rates of their payments, the rate of fraud on these payments, and then the cost of those payments themselves. And obviously these three things can go in sort of different directions. Things that might make payments get authorized can also make fraud go up. In order to do this, we sort of have an underlying sort of contextual bandit that can pull one of 600 levers. The number of levers isn't fixed, it grows over time, sometimes we remove them, and then sort of like behind the scenes, we choose to represent the causal estimate of our impact to our customers in a UX so they can sort of see what we're doing. And so you can think sort of every single stage of this process involves A/B testing, not necessarily to make a decision, but rather to change the system that we're operating under. So for the lever discovery thing, we have a sort of system of exploration, exploring potential new levers we could add based on feedback from our customers, observational data we have, all sorts of things. Second, we randomly explore our training space in order to determine what the optimal lever is across our sort of like three parts of our objective function. And then finally, we run a lot of A/B tests to better understand how our customers interact with the system itself. And so I think you can sort of think of online experimentation as being critical to every part of our system, from how it's designed to how we improve it to how it's exposed to paying customers. What about you, Guillaume?
I mean, for me, it's a little, so I'm at Roblox. For those who don't know Roblox, ask your kids, they'll explain what it is. They probably know. But essentially, it's a gaming platform, multi-sided market with players and creators and pretty long tail on both sides, like very diversity of games, diversity of tastes. A company that's very focused on the long term, and a number of kind of like safety kind of and sensitive things, and also tons of heterogeneity. Like different games are very, very different, and it turns out it's very hard to understand what a game is. Like if I show you a picture, you're like, oh yeah, it's a picture of a mountain, right? But well, how do you describe a game, right? And so in terms of the things that we care about it, I mean, when it comes to going beyond AT, I think it's very simply like just Kates or like HTEs, because treatment effects are often very, very different. I'll give you one example, maybe two of what we care about. So different games have very, very different latency sensitivities, right? So for some, if you play a first-person shooter, it's very important that like you're on the same server as the people you're playing with and that they're close to you. But if you're playing chess, you want to play with someone who's the best player to match you with, and it doesn't matter if like it takes longer, right? So oftentimes the ATEs will actually be misleading because we want to personalize the treatments for different genres or different game loops or things like that. Another one is we really care about long-term outcomes, and so how do you make sure that like you give creators the right incentives to create games that are going to power the platform a year from now, 2 years from now, but and that requires essentially just using a mixture of like causal inference and short-term experiments. So these are kind of like some of the two main use cases that we have. Happy to talk more.
And so just specifically with the long-term stuff, then that's kind of also using these experiments that you might have conducted for a particular product change to understand the relationship between the short term and the long term, or?
That's right. And also going back and forth between like causal inference and experimentation. So using one to validate the other, using one as input to the other, just kind of refining constantly. Yeah.
Yeah. Cool. Bilal, you warned us you had an unusual take here. So.
Oh, it's an unconventional. So I'm fully aware that I'm a conference on digital experimentation, so my answer is going to be unconventional. I also want to sort of start by saying that I started my career in academia, so I fully appreciate and understand the importance of experimentation. I work at Duolingo, and we, by the way, how many Duolingo users in the room? Yeah, lots, right? So what's your, probably hundreds of days of streak. So it's an addictive app in a good way. So, and people are proud to say that they're Duolingo users. So we run hundreds of experiments every quarter, and they're running consecutively across user growth, or across monetization, across sort of improving our learning, sort of learning metrics and teaching better. We do all the things that have already been mentioned. We use A/B testing or randomized data to improve our ML models. We do heterogeneous treatment effects. We do surrogates to understand long-term effects from short-term data. But I think what's really important for me to say here, which is my unconventional answer, is that A/B testing is simply a tool. It's not the end-all, be-all of what we do. We make business decisions with a flashlight, which is A/B testing, but it's not sunlight. We have so many other things that go into business decisions in terms of setting long-term strategy, in terms of where to invest. Maybe we want to go into a new market. All of these things are informed by things that are more than just experiments. So from a business perspective, yes, running experiments is really important, but the answer to business success is much broader than that, and we can't have tunnel vision when we think about experiments as the only thing that we focus on. Obviously, we do them, and we do them well, but we kind of layer them with a lot of business intuition to make decisions. So that's my unconventional answer. Happy to go into technical details of what we do in experiments as this panel progresses. But
actually, I just want to follow up on that. When you say business intuition kind of being layered on top of that, what form does that take, and to what degree does that involve centralized decision-making based on the results of experiments, or is that kind of more diffuse intuition throughout the organization?
I think it's both. It's bubble up and top down as well. So, so our product leaders and design leaders, as well as data scientists, are actually very empowered to bring ideas. A lot of those ideas are actually sort of by osmosis informed by past body of experiments that we've done. But also a lot of ideas come from the top. So in terms of their intuition and where they want to see the business go. So the C-suite will provide their ideas, and then we meet at the middle.
Cool. Yeah.
Just for the context, I work at Lyft. I've been there for 2 years. I started out my career working at Meta. Experimentation was simple. I actually working on growth. So it's like everything was clear. You launch an A/B test, you run your power analysis, you actually run it for a few weeks, depending on your power, and then you decide to launch. Everything is clear, simple. You keep a holdout at the end. Then I moved to Airbnb and things get really messy. I got into kind of personal, desperation because you have so much interference. You got network effect. You actually a two-sided marketplace. Experimentation get messy really quick, and then you actually underpower because you don't have that many listings and many users. And then I move on to Lyft. And now I actually kind of accept the fact that experimentation is actually never perfect. It is actually it's a messy business. Actually, that has come to the term of acceptance. But basically at Lyft, it's like a very cutthroat business. We are in ride sharing. The margin is always so thin. We have a big competitor going outside. Anything that we did wrong, it can be fatal. So experimentation itself, outside from just doing a normal launch or no launch decision, is actually powering a lot of a market insight. So we have continuously running experiment to understand market sensitivity. We actually want to understand how driver responds to incentive. We actually have to think about how user or session or with right intent actually responds to coupon. All of that together is actually powered by and then you can build the most sophisticated machine learning algorithm from observational data itself. But sometimes that is actually not enough. And empirically speaking, having a exogenous experimentation to have with a machine learning problem for the algorithmic development is actually very important. Also at the same time, it's not only for ML algorithm. We think about okay, does the market change over time? How does prime time change? from one region to another. And that kind of thing is like a two-sided thing. So we do have to run like occasional experimentation to understand the two-sidedness, like how driver and passenger react with each other. But that one is like kind of like a time split experiment. So obviously you cannot run it for a very long time. You have like certain number of weeks. But at the end, you actually have to actually keep in mind, like I think the most important thing when we run experimentation, as Zia say, is actually not sunlight. And we have to be aware that there are things that we don't know, and keep looking over your shoulder to figure out like what is the big thing that lurking around.
I don't know if everyone from Meta in the audience was insulted when you said that experimentation is easy at Meta.
No, I mean like it's actually like basically okay. Disclaimer: I work for growth, so it's somewhat like. Probably like the advertising people probably have harder time. Okay, don't come with me on that.
Cool. So I think maybe related to some of what we touched on so far, I want to ask, how are you using multiple experiments, right? A lot of times you have a rich experimentation practice, you end up with hundreds, you end up with thousands of experiments in kind of a corpus of experiments. What are you doing with those? What sort of meta-analyses or other ways of revisiting past experiments are you using? Yeah, Brent?
Cool. Yeah, I guess I have a couple different answers. Before I was at Stripe, I was at Twitter for many years, and Twitter had run, by the time that I left, tens of thousands of experiments. And one of the things that we built towards the end of my tenure at Twitter with Robert Neal, who's perhaps here somewhere, was sort of a categorization system to taxonomize and categorize experiments based on sort of their underlying causal mechanisms. So you can pretty much imagine these mechanisms from first principles for a social media platform. You've got experiments that send emails. You've got experiments that send push notifications. You've got experiments that do this sort of congestion effect stuff where you move around the who to follow module. And then on top of that taxonomy, which was pretty easy to discover, we aggregated effects sort of based on what the underlying change they were making within that mechanism was to help inform future experiments. And I thought that this taxonomy was like relatively very effective for the existing product teams because the rate of turnover on those product teams was so high that they would lose sort of the underlying lore that perhaps we tried to put the most popular people in the who to follow module, and it actually had negative effects because it displaced people who would benefit greatly from follows. So I thought that taxonomy idea yielded a lot of fruit from like relatively little supervised data analysis because you can use sort of like organizational factors to cluster. I think at Stripe, the main thing I'm on the lookout for, and please DM me if you have any ideas, are new levers to pull, right? Like it's fairly straightforward once something is a lever within our model for us to like begin to explore when to pull that lever, how often to pull that lever, what combination of levers to pull, et cetera, et cetera. But the sort of like unstructured out of sample space of like all the different things you can do to a payment, it's probably bigger than you imagine. And so we do a lot of talking, like a lot of sort of evangelism of both talking to product data science teams, of talking to Stripe's customers, of talking to sales teams about things that they perhaps have heard that are easy ideas to test. Then on top of that, we have a very fun system, sort of connects to something Ramesh was saying this morning about throughput, of like once you have an idea to test, can you just like blast it out there on the maximum sample size possible and get some signal about the sign as quickly as possible? And if the sign is remotely positive, you stop, then you do the work to add that as a candidate. Kind of a high level answer from two perspectives.
Yeah, I mean, actually, just picking up on that first part, I wonder how's the process changing of trying to taxonomize, summarize, and search existing experiments. My sense is, hey, we've had all these huge advancements in natural language processing in the form of large language models. Mm-hmm. Is that something you're using to understand the space of what experiments have happened, what innovations people are trying?
Yeah, that's a great question. So at least at Stripe internally, we have an LLM connected to sort of all of our past history of like shipped projects, shipped emails, shipped experiments. And so one thing I do all the time, right, is I'll ask it, like, have there been previous experiments on the use of spacing and capitalization in postal codes, which I realize I make my job sound very boring, but surprisingly, it's a very impactful thing. And then it will return to me sort of not only all of the various experiments we've run, but the code changes that have modified the parts of the code base. And then from that, I can do pretty comprehensive literature searches of the impacts of spacing and capitalization in postal codes, and then derive from that sort of a working theory. And so that was something that didn't exist when we built the taxonomy at Twitter, and we had to do a bunch of sort of like database curation in order to even get to that stage.
Yeah, same thing. I would say even like a lot of time people find experiments without data science involved at this point, which is like there's enough search engine. There's a really good internal search engine. Every document has every experiment has a write-up, and so people will type questions at this point. any sort of question. Hey, what can you say about X? And then it will often surface like past experiments with a pretty good summary. And so at this point, I think there's probably less of a need to like taxonomize and kind of go super deep and finding a methodology. I think like some of these elements are pretty good at surfacing these things like directly for us. I'd also say like sometimes there's a benefit to having fewer experiments in the sense that people really remember them. One thing that struck me when I joined Roblox is like very senior people were talking like, hey, remember this experiment we ran 6 months ago and it showed X. And so either having fewer or having a clear kind of leveling of like, this is a really important experiment that we're gonna socialize a lot so that people remember it. Because I feel like that part, experiments just being an input to people's kind of intuition to the point about, leadership and the kind of decisions being made without sometimes, something else than just data, right? Like building this library of stylized facts that people keep in their mind as they build their business intuitions, especially at the senior leadership level, is really valuable. So these two things have been helpful.
Yeah, so I think at Duolingo, we have a fairly sophisticated homegrown experimentation platform where we've made it super easy to set up and run experiments and analyze experiments. So most experiments are run directly by PMs, product managers, with no data science involvement, and the metrics are auto-generated, so they can even analyze the results. Now, where AI has really helped is actually it solved a incentive misalignment problem. So I'm an economist, and obviously humans make decisions if they're incentivized to make decisions in the way that one hopes. When setting up hypotheses, setting up sort of theory of change, product managers were not incentivized to write detailed theories of change or what the hypothesis is. You pick a random sample of whatever, X sort of experiment setups, and the hypothesis is increase DAUs. That's the hypothesis. What do you learn from that? So like 6 months down the line, when you go to that experiment report and say it was launched or say it was shut down, we don't learn anything because we don't know what the starting hypothesis was. So where AI has really helped is actually automate that generation process. So now we have detailed hypotheses in the documents that are there in a repository that then a different AI can call later on and sort of solve similar to your problem or similar to your solution, sort of a central library that AI can say, okay, in the past we ran this experiment, it was shut down, here was the hypothesis, here's where the results broke down in the theory of change. Let's go try solving it with a different type of hammer, essentially. That's been super helpful.
Yeah, I think that's really interesting because, Guillaume, when you were saying, oh, you can search for these experiments, I worry about sort of an internal version of publication bias, right? Where, if you aren't sort of looking at the whole universe of experiments that were run because a bunch of them don't have good metadata, then you start to pick on these ones that, yeah, sometimes they're iconic, they're great, they're memorable because there's some clear stylized fact, but sometimes they're also kind of cherry picked. So it seems important to make sure that's all in there, I guess.
That's right. And I think AI can help there potentially, right? Like one of the things we've been doing is like AI actually starting to review experiment proposals and give feedback and like, hey, do you actually have a hypothesis? And like, or another thing that happens is like, are you changing your launch criteria from your original hypotheses? And so hopefully like with that kind of additional, which would not be feasible to do like with humans. And so hopefully that guarantees like, some of that.
And I know maybe you could say something directly about this, but also too that you were mentioning kind of these long-running or recurring experiments to estimate things about market conditions. It seems like those are cases where you might be looking across many of those experiments you've run before. Is that, or you just always look at the most recent one?
Well, basically, these experiments are continuously running. So we already they are like the set of canonical experiments that we have. But at the same time, you imagine we run like 1,000 experiments. And basically, talking about AI, actually, I went to a lot of experimentation review as part of my job in terms of customer study. I have this guy. He can actually know which experiment gonna work or not with the accuracy probably 80 or 90%. And then I was questioning myself how does he know like that? Does he have Oracle? This guy is a psychic. But actually it turns out it's actually come from years of product insights, from sitting in experiment review, from talking to people, from chatting on Slack, from reading design doc. The problem itself is that like, how do we actually compose these corpus of knowledge and feed it into the AI system? Because like sometimes the conversation can go rub, 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 rub. An experiment, people keep chatting for like 60 minutes and they come up with something. But come on, like how does we use, like how would an AI, like we have to take note, guys. We have to keep things in documentation. And later on, we can actually, so documentation would be like a very good thing for people, for the AI to make it searchable. But also like, I just want to say that I am a contrarian. Basically like, when you guys think about that, so we already know, like if you actually work on like a product specific domain, you kind of have an idea like what would work and what wouldn't work. The problem itself is that you don't know what you don't know out there. And sometimes like if you just use like AI, for example, we can use like AI or even like just straightforward like machine learning in some talk here and to predict whether an experiment gonna success or not. Sometimes we actually limit ourselves to our blind spot because there's like gonna be like the thing that we've been trying forever and forever. And we actually like just kind of limit ourselves within that box. And we actually have to have a mechanism in which ourselves, like we have to encourage people to come out, to try new ideas, even though like the algorithm say that 80% of the time it's not going to work. For example, like intuitively, like making like login two-step, it's not going to work. It's very hard. Like it's actually you add friction. But what is the long-term impact of adding like two-step login? It's actually something that you actually need human. Like the part of the human, like we keep ourselves, like remember we are human. We have to be like somewhat like a better than AI at this point, at least at this point, to actually keep our blind spot clear. Like we have to keep in mind.
So really, can I just say one?
Yeah.
Just tack on to that really, really good point, plus 1,000. I think it's very easy for a business to iterate itself through experiments into a deep hole. And I'll give you an example. And this is a sort of public example. The CEO of Groupon, former company, said this himself. So this is not private knowledge. But basically, they started sending notifications by email to their users saying, hey, you know, use your Groupons. And the first notification worked really well. And the PM team went back to them and said, hey, this worked really well. Now let's send 2 notifications. And then they sent a second email and then said, oh, that worked really well as well. Now let's send 3 notifications and so on. And you know what happened in the end is basically that whole notification channel shut down because users started ignoring the emails. So it's very easy to iterate, keep iterating yourself into a place where you completely shut down the channel, which is previously very effective. So that's where experiments alone can't drive business decisions. You really need some sort of
The intuition
and
the gut, like courage, like it's okay. You're gonna get peep at some point, but guys, might be your big break in your career. Sorry.
And maybe just to riff on that a little bit, like one thing that I've noticed one thing I've tried to do in my career a lot is like just increase adoption of experimentation. And it went from, some places went from experimentation being an unknown thing that we should just introduce to something that has sometimes a bit of a bad name. And so that's something we should be aware of. For a very similar reason, which is sometimes associated with like a lack of conviction. So if you don't know what you're doing, you're just going to A/B test your way, and also essentially either local optima or actually completely like just bad outcomes. And so it's kind of a new thing that we deal with, which are kind of some.
You throw everything to the wall.
That's right.
Probably something gonna stick.
So plus one as well. Yeah, exactly.
And I think some of these notification examples are really ones of where there's great evidence that often the short run effects are so different from the long run effects. And one of the things we were having a conversation about this the other day was just needing to rely on intuition and product knowledge to assess when are the cases where the short run effect is going to look different than the long run effect. I could also imagine that being a case where a corpus of experiments could help you if you do have some of these long running experiments.
Yeah, I think that there's a strong need to systematically measure the long-term effects of changes made to companies, but that strong need has a far less institutional incentive than measuring the impact of short-term launches, right? And so I know at Facebook, for example, they have all sorts of holdbacks to sort of gauge the optimal amount of notifications that you can send someone. And so I think that like a good complement to a robust culture of experimentation with like high throughput, testing new ideas, shipping things that work, is a robust culture of holdbacks and reverse experiments. And beyond that, like a commitment to measure the sort of like going from, effects to causes of what you are doing as a business beyond experimentation in general. And that's something I think that's very difficult for businesses because they're so incentivized to be doing new things that looking back at like what you've shipped in the past is systematically very hard.
Yeah, I want to follow up on that, but I also want to make sure that we're going to start taking questions from the audience. So if you've got questions, I think we'll have a couple microphones going around. Kind of to follow up on that, what are the techniques that you're using to try to evaluate whole programs of experiments, like maybe a whole series of attempts in an area or the total impact of one team? People I know use holdouts, or they call them holdbacks, et cetera. But there's other approaches here. What are each of you doing in that kind of area that can be somewhat backwards looking, but often can be so useful?
I'm a bit of a contrarian here. So basically, when you run experiment, there is a cost. There's a cost to the engineer. There's a cost to the user themselves. You don't want to keep the user too long in one variant that you actually know that is actually harmful. So basically, keeping a holdout, keeping team responsible, keeping the prioritization, the org prioritization in check, like which team should get more resource than the other team, is actually very, very important. It's actually important for corporate reason. It's corporate for all this kind of finance prioritization. But in the grand scheme of things, if we run 1,000 experiments, and you make around 10% wrong decision, and around with that you can make 90% correct decision, I think honestly, personally, I'm okay with it, with the cost. Yes, you actually there are things that you can do. For example, all the back-end change, sure, you should keep a holdout. But for example, for things like a front-end change, keeping a holdout, you have to be very cognizant of user lashback. Things like two-sided marketplace, you cannot actually keep a holdout. You're actually lucky that you can even run experiment. So yeah, but then basically keeping a holdout is important, keeping the number unbiased is important, but somehow just making the org itself, the ship is actually steering in the right direction, I think is the biggest mission for data scientists.
Yeah, I actually agree with that. I think from a data science perspective or an econometrician perspective, yeah, everything should be a holdout. But that doesn't always align with what the business needs, right? Because maintaining a holdout is from an engineering perspective, really costly, especially at a company like Duolingo where our app is changing daily. So maintaining a separate, essentially, feature set for people in the holdout is super expensive for us. So we actually very rarely keep holdouts. We have...
And maybe some context for that would be what does typical experiment duration look like before the launch decision?
Yeah, so we do power calculations, but on average, I guess the median is 2 weeks, but there's a confidence interval around that. And so I think the purpose of holdouts for us, at least, is we want to at least get signal and novelty or primacy effects, right? Because that's going to end up affecting how we add up experiments. And we do winner scarce adjustment, et cetera, when we add up a sort of compilation of experiments. A lot of times we can get some signal just from the experiment period itself. So one of the benefits of a longer term holdout is that we can accurately measure these things, but to his point, it doesn't matter, especially for a company like Duolingo where we're on the backbone of our S-curve. Lots of things we throw at the wall actually work. So in that sense, we are, as long as we're moving in the right direction, we're okay with that. And I know that maybe is an unconventional answer in this room, but that's kind of a business reality because we have to weigh the cost of a holdout versus the potential benefit we'll get. And a lot of times, sometimes we do holdouts, but a lot of times we don't for that reason.
I would say at Roblox, it's almost the other way around, where sometimes it's easier to argue for a holdout than for an A/B test. And part of it is because of this kind of caring really strongly for the long term. And so it's almost the short-term effect is whatever it is, but does it take us towards our long-term vision? And so we get a lot of mileage out of holdouts. There's quite a few of them. We review them every month. They get socialized to the whole company. And so, yeah, I think it really depends on kind of where the leadership is in terms of what they care about. And I guess you could arguably we're maybe in a different place in our S-curve. And so there's really this idea long-term, what does this mean? And so, yeah, in general, it's much easier to get a holdout started.
Yeah, I think that's interesting. I mean, in some sense, reflecting this different level of uncertainty about what the relationship between the short term and the long term is, and we might think that those are those are different in some of these settings that we're talking about, right? If you're confident that, hey, if this is increasing how much DAU, how many lessons people are doing in Duolingo now, it's probably also going to do it later, whereas that may not be true in a bunch of other kinds of settings. Yeah.
Yeah, I guess I have sort of two answers that conflict. I think I think that the first answer towards this like business value stuff for the long term is to just have like a strong, to the extent you can, theory based on empirical learnings about what is success for your product, for your business, and then have some like robust tests and metrics to connect what you're doing locally to the validation and refinement of that theory. That sounds a little bit obvious, but I think that like, I believe it was Tu who was saying, or maybe it was Bilal who was saying about DAU go up. We often have very weak theories in industry about like why things work and other things don't, and like what makes our product locally very good, and just have like these global metrics that we're ascribing things to. And so one thing that I do with my team regularly is work through sort of like our theory of why the things that we're doing locally connect to like actually increasing revenue, connect to like the second order impacts of people paying for our product, signing up for our product, churning from our product. And then the second thing I really want to push on here, beyond the theory, is having the courage to really perturb your space. And I know, like Tu mentioned, there's a cost to running experiments if you know one side is going to be better than another, and you can calculate that. But there's also a cost to reaching these like local maxima based on overprescribed theories. And if you would believe our performance on the exploration data that we've put a ton of effort into curating for our model, we are great. Like that's right, we are great on my product. Every lever we predict is almost always the perfect lever. And so we put, and so we solve the problem. And so we put a lot of effort in ways that are somewhat random and somewhat regular, completely breaking things, right? And seeing how like a completely broken model would do, or seeing how just like naively pulling a certain lever all of the time might do. And from that, we learned that our system is really far from perfect and far from a local optima. And I think introducing some like regular set of like very dramatic perturbations into what you're trying to do as a business is very helpful for then, in turn, improving this theory.
Yeah. Okay. I want to make sure we get to some of the audience questions. Do we have someone with a question?
Me?
Yeah. Maybe Li Hua. Yeah.
Thanks for the refreshing panel. So it feels interesting that 10 years ago, when this conference sort of got started, you heard a lot of examples on the other side, which is, well, look, the product sense is going so wrong. So someone thinks this is going to work great, and then if you test it, they prove wrong. But nowadays, we heard a lot of the opposite examples where A/B tests could go wrong and product sense can dominate. So I guess my question is, or my sense is that the A/B testing can dominate now in industry because it serves three goals. One is rigor, right? You provide statistical rigor. Second is automation. You provide velocity. And third one is discipline. You guard against bad incentives. So because all of these features, A/B testing becomes so powerful. But now, if we shift from the A/B test to sort of getting more product sense into the pipeline, then there got to be something similar to A/B test that's gonna thrive in the next decade. So do you have any sense of what's the next thing that the companies need to do in order to get something similar to A/B test over the past decade?
I want to correct it a little bit about the understanding. A/B test still like the gold standard, and everything, like most of the thing that we launch is actually rigorously examined under an A/B test. But as people see in the panel say here, we can A/B test to the death of it. So one idea can be good, but then you can like 2-3 different similar idea can kill the product. So that's when we actually have to be cognizant of the like limitation of the A/B test. But yes, we launch most of the stuff is a very data-informed decision, and we have to be because like we have like it's a very cutthroat business. Everyone tries to maximize like tiny delta. So yeah, I don't think that you can go without A/B test.
And I think maybe your example of this person who had this great product sense, where did they get that great product sense from being in so many experiment reviews, right? So I think that's an interesting observation. That is that, you know, to the extent that people are getting better at predicting some of these results, or that a lot of that is coming from accumulated knowledge from experimentation.
But also, I think like there's a maturation as well. 10 years ago, A/B test is a new thing. Now we use it. We understand that it's actually very effective, but we also like be more humble. We understand the limitation. It happened for every single product cycle. It's like iPhone was out, it's great, it's life-changing. Now we say that we need to go on abstinence, like turn off your app. So.
Yeah, I think
From my perspective, I think what you stated are not, those two things are not in conflict in my mind, because A/B testing is a tool. It doesn't tell you what to A/B test. That is something where product sense comes in and tells you what is the right hypothesis to test. So I think that those two meet in the middle, and that's the powerful combination.
I think that one thing that's really fun to think about in this vein is that 10 years ago, right, online experimentation was all the rage. RCTs, easy to design, you can build these platforms, you can analyze them. And people frequently speculated, you know, will the same thing happen with observational causal inference? And it sort of like never has. And as far as I know, no company has like a widely used observational causal inference platform. I know maybe LinkedIn tried to build one, but there's never been sort of like, there's no equivalent of perhaps code for observational causal inference in industry. And I'm kind of curious why, like at your companies, is there systematized scalable observational causal inference? Do you use that when you're informing experiment design? How does that work?
I'd say we use a lot of observational causal, but I don't think there's not a, first of all, like, I mean, the benefits to actually platformizing are probably not what they used to be. There's a lot of really good open source package. Like it's, you know, a lot of the benefits of, I mean, what we tried to do this 10 years ago at LinkedIn, it was pretty hard to like run observational causal, but the packages were not quite as good. So we need to add some stuff to it. The scale was an issue. So I think there's a lot of stuff that we had to do that nowadays is perhaps less necessary, where like, I think a good empiricist who's a good data scientist can like crank out a pretty good study in like a week, or 2 weeks or something like that, which might have taken months before. And so perhaps just, I think I still see it used all the time, in part because of focus on the long term. But I just feel like it's perhaps easier. It still requires a lot of thinking about your hypotheses and your identifying assumptions. And I don't know what the benefit of a central platform is anymore.
Yeah, I want to add to that, to the causal inference. So when you run experiment, think it's straightforward. You got yourself a t-test, like everything, you have a platform for that. But now you move on to like observational causal inference, it becomes like everyone cook their own dish. Like you got a data scientist from different background, they throw in different variable, they throw in different time lag, they look at metric at different horizon. They look even the metric definition itself is not even unified. I think like for observational causal inference, we actually need the need for to have a platformize that kind of product, like officialize, like what kind of covariates we have available in a company, what kind of metric, what kind of metric definition, what is your complement group, what kind of time horizon you look into is actually even more important than experimentation. So that every single product itself got measured by the same tape. And we actually I assume that every single company is like looking toward a platform for like systematically doing observational causal inference.
We tried to do that actually at Amazon, not at Duolingo, when my previous role was at Amazon, and it was just so hard for all the reasons people have mentioned here. Every solution is different. It's very hard to standardize.
Yeah.
So yeah, I think they're still trying to do it, and it's been 5 years. So
Yeah, but like there is a need, right? Everyone cook their different recipe. At least people should have come up.
But I think it's almost like what you really want to automate is like, it's more like the peer review process or something like that. Like what really makes a causal inference good is that you go to a seminar and people criticize it to death, and eventually maybe you have something believable. And I feel like, you know, AI can help at least, you know, question things and kind of make sure that like you've thought about different things. And so in my mind, yeah, like we definitely need a metrics platform to standardize measurement. That's definitely true. But I think there's still no great substitute for like feedback on your actual empirical study. And that's perhaps where there's a lot of opportunity there.
it would be actually a great business idea is to actually automate lunch seminar feedback through AI.
Without some of the painful process of that, yeah. Do we have another question over here? I think it's just on.
Is this on?
Yes.
I guess the question comes from, so you're running all these individual A/B tests, and it's almost to me like engineers just having an idea without theory and just testing it, which is not bad in principle, as you're kind of saying, because it might work. But I guess like how do you incentivize different product teams to have and invest into theories and overarching learning rather than just testing things one by one. Because oftentimes it's like, oh, like a person learns something over 2 years, they get laid off or they leave the company, and the institutional knowledge just disappears, rather than the team itself having this kind of like institutional background knowledge of like what works, what doesn't, and why it doesn't, or does. And I guess also the follow-up question there is like, how do you think about the context of AI in this way, where it's like, AI generates better documentation, yes, sure, but like, do individual product managers actually use it in a way that makes it some form of like overarching thing?
Maybe I can just say something quickly. I think the spaghetti sauce risk is definitely there if we consider A/B tests in a vacuum, but we don't run A/B tests in a vacuum. The product managers are incentivized to think about their program. So they run this test, they get a result from this, what are they going to do next, and what are they going to do next, and what are they going to do next. So they have to think through their whole experiment pipeline, and that necessitates them to think about the whole arc of product development. So,
And when you say they're incentivized to do that, what form does that take?
because their performance is assessed in that way.
Yeah,
People are
usually-
expecting when they're proposing or presenting the results of one experiment that they have.
Yeah, so
They
they get asked. So we have a product review process. Every experiment that's rolled out actually has to go through product review. And in that product review, it is expected that you are going to come up with what are you going to do next if this wins, for example.
Yeah, but I also I want to add to that is that engineer doesn't do random thing. That's actually far from it. Usually they have very good hypotheses. When you write your experiment spec doc, you usually have to have a very clear idea why you actually want to test this feature. For example, I say okay, this pricing algorithm, I think I'm going to over-index on supply constraint region. I have evidence empirically to show that. Now I just want to A/B test. So when you actually do because when you think about engineering resource, it's actually very scarce. You actually the process to allocate engineering resource to work for a certain product is actually itself is very rigorous. So also when the experiment come up, when you actually review the experiment result, it's not you just look at top line DAU, for example. As Brent said, you have to have a very clear hypothesis. You almost have your brain into a causal graph, why the feature worked the way it worked. What is the mechanism for the DAU to go up? Is that people open the app more often? Is that we crash the app more often and people get frustrated or they left? So there is a certain, and then basically the experimentation platform itself, you don't look at 3 metric, you look at secondary metric, you look at slicing, dicing, you look at specific group of user, you look specific cut of the metric to actually try to understand what is going on. So I mean we say a spaghetti throwing on the wall, that's probably a true cause, but usually the process itself is actually pretty rigorous within a within a organization.
I would add maybe Roblox takes it even one more notch or something where we're trying to be extremely transparent. So one thing, for example, our recommendation algorithm, we're very open about how it works and things like that. And for important experiments, we'll actually, because it impacts the livelihoods of game developers, we actually will publish before we run them. We'll say, hey, FYI guys, we're going to run this, and you might see some impacts, and here's the rationale. We just published one of those on Monday or Tuesday. And so, yeah, so we can't go in front of the developer community and say, we're just going to try random things. It's going to affect some of you in different ways, and we'll see what sticks. So the need for a rationale and a theory of change is really important there because of transparency.
Yeah, I think that's great. And let's actually go to another question so we can get a few more in. Yeah.
Yeah, thank you. This has been great so far. So we come from a universe where our experimentation is actually very much in service of brand marketers. And so it's a very different, I think, direct to platform is a very different universe, but we're trying to apply a lot of those same concepts in the structure of what we're doing. So you talked a lot about historical data and the role of kind of the aggregation of those outcomes from historical experiments. We end up talking a lot about confirmation versus exploration and live very heavily in a confirmation universe, trying to shift other thought into more of that exploration space. I'd love to know what you think the role of that historical data looks like in kind of mining for signals that might prompt in the exploratory space.
Yeah, I think we've touched a little bit on idea generation, but I think that'd be a great thing to dig into more. Yeah. How are you coming up with more exploratory directions?
I think a lot of that rely on a product intuition. I'm so sorry to say this, but like a lot of stuff is actually not replaceable by AI by just looking at the same thing like all over. But at the same time, like when you look at like the whole like code program, you can see that like there is a lot of promising idea of using AI with like a lot of human tuning for like additional product development. And that is something that we want to actually check on. At the same time, if you are like a platform, you probably like try your best to actually make it really easy for the user to run A/B test. B, try to actually minimize any kind of user cost and think about like, oh, this guy got real metric. C, actually have very clear launch criteria, have a metric platform. So all of these things work together. I think like with the human intuition, with all these mechanics like AI tool, experimentation platform tool, I'm pretty confident that we actually moving toward the right direction.
Also, yeah, go ahead.
Oh, no, you first.
I was going to say, like, in my experience, also surprise, like these confirmatory experiments. One thing is like sometimes they surprise you, and that can actually be a great kind of catalyst towards like thinking about being more kind of exploring more things. And so I've seen this happen a few times where an experiment is just run just to confirm there's no issue, and then we see a really surprising result. And that I think, something that just makes you like, oh, I have no idea what's going on. Like that's usually a great moment in terms of creativity and figuring out like what are my hypotheses. And so when a group of product leaders sit down and like, we spend this money, we try to do X, nothing happened. Like why not? And so in my mind, like one kind of leads to the other, and making sure that your CI/CD or your release management is set up in a way that you run a lot of experiments just to confirm, make sure that at least do no harm with that kind of stuff, right? Those surprises, assuming like they're not false positive, but like can actually be great catalysts for that.
And those then are maybe some of these experiments that you mentioned get kind of really socialized across the organization, that people know those stylized facts from these surprises.
Yes.
Yeah.
Sometimes we have to temper that a little bit too, but yes, that's right. Yeah.
Yeah, I mean, I think one of the fun undercurring themes of debate of this conference is sort of like the serenity prayer, and to a certain extent, which is like, use the fancy methods if you have them. If you don't have them, maybe don't use them. But the most important thing is sort of to have the wisdom to know the difference. When do congestion effects matter? When do network effects really matter? When do you care about like not having enough out of distribution data? And I think those questions are very salient to your specific application in brand marketing, because randomization is very difficult, right? And like, in my experience, it's like having a local advocate who has sufficient institutional power to advocate in our particular circumstance. The fancy shit does matter. Here are 99 theses for why it does matter. And so we're going to need to do QR codes on our ads, and we're going to need to find like the best comparison cities. And so when I talk to especially brand marketing teams, my suggestion there is to convince your leadership that actually brand marketing is very important. It's just very hard to measure. And the only way you either accept it's important, hard to measure, and it's like the wagon maker, whatever that quote, or you invest in the fancy shit. And I've actually had pretty decent success organizationally, both Stripe and Twitter, in investing in the fancy shit. So I'd encourage you all to do that. And there are probably many people here who can help you think through like designs for collecting maximally informative exploration data.
Okay, yeah, we've got another question here.
So I'm going to ask a very nerdy question, which is, what is the role of economic theory or game theory in your decision to try new experiments? I'll give you one example. So I use Duoling, and we have status contests, right? It's a very well-developed theory. And the top status category should have one element. It's also fairly robust. But if I look at the leaderboard on Duoling, it started with 7 in the top status category, and now it's, I think, 4. So my puzzle was, why is it never 1? And does game theory actually have any impact on things that you try?
Yeah, it's a good question. Yeah, so we do, definitely in terms of leaderboards, we are thinking about, it's a social experiment, right? Because we can't expose you to a change in estimation because you are operating in a social environment. You're competing against others in a leaderboard. So there is definitely a component of theory that's very relevant there. So we are thinking about those things in the way that we come up with hypotheses and the way we run experiments. Other places where economic theory is really helpful is coming up with demand elasticities. So if we're thinking about pricing, and then also package mixes. So what affects demand elasticity? What's the shape of the demand curve? What are the different determinants? What kind of experiments we can do? And then it's not just price elasticity, there's cross-price elasticity because we have multiple packages. So those are like two examples where what we do and what we try and how we come up with hypotheses is informed by economic theory.
I'd say, like, yeah, Roblox is also a lot of econ in there. I mean, we have a whole virtual currency, right? So you can buy the currency, and then in there you can use it. People can trade it, and so we have some markets that work, and some markets that have market failures, where it just unravels, right? And so, literally looking at that, and this is what drives like our hypothesis generation. Like, do we need some sort of property rights? Do we need price floors? Do we need like all these things, right? And so a lot of it comes from economic theory. Yeah.
Any other examples of that kind of thing popping up? I mean, in some ways, there's the parts where it's obvious that it shows up maybe in pricing, right? But then these other cases that maybe are a little bit more challenging because maybe we're a little less confident in the theory, like some of the social comparison stuff, I guess. Yeah.
Yet another one, perhaps, like that's also like so for creators, it's really just about incentives. Like when you create a game on Roblox, we make it much easier than other platforms to create a game, but it is still a huge time investment. And so there's questions about like, is it rational for you to do that or not, right? Or are people just profit driven, or is it because like they also just enjoy the process, and that kind of leads to like slightly different kind of product takeaways. And we also think that you can look at things like concentration of outcomes on the platform, like essentially the analog of inequality, but like kind of on the Roblox platform, that probably changes people's incentives and decisions to engage or how to engage. So we also think about those things. Yeah.
Right, which could relate to something like understanding the kind of risk aversion or risk seekiness of these creators.
That's right.
Yeah. Cool. I think we have another question over here somewhere, right? Is that, or no? Well, I have another follow-up question because there was a little bit of a question about how AI is changing things, and we've kind of touched on some of those ways. What, besides what we've covered so far, are the ways that maybe AI, maybe specifically LLMs, maybe multimodal stuff is changing experimentation practice, or that you hope it changes experimentation practice if it's not doing it already?
Cool. Yeah, I guess by virtue of being most proximal to you. I'm a people manager, and I think one problem I often confront is understanding and measuring whether or not I'm actually adding any value. And that's like, hopefully no one from my organization watches this video. And that's like a much more nuanced question to evaluate than you might think, given the emphasis on sort of like both latent and long-term metrics here. And one thing that AI has really helped me do is have a much stronger firsthand opinion of my team's work. Like a couple examples here. I recently implemented my own experiment for in our own like Java code base. I ran the experiment. I implemented sort of like the token, the unit of randomization, and like got a very firsthand experience in terms of sort of like what a project for my team would take. And then the second thing is I sort of effectively built out my own model as part of our product, and I'm like working on some like beta testing. If anyone here uses Stripe, reach out, experiments to monetize it. And so I'm having like a much greater firsthand experience with what my team does, and that gives me a couple of different very valuable skills in order to assess my own performance. First, like much more tightly bounded empathy and understanding for the time and difficulty that things will take with like a pretty good expert system to give me that feedback. Second, the ability to, and this, again, might sound a little dystopian, but to have the ability to sort of evaluate the difficulty, complexity, and time requirements of the things that my people are doing without bothering them with a ton of questions, right? Like, how hard is this? Why did you do this way? Blah, 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 blah. And then I can come into our meetings both better prepared and with stronger opinions of how we should shape our roadmap. And so taking a step back, personally speaking, the first order impact of AI on my career has been to help me have like much stronger and better calibrated opinions about like how I'm doing in my role vis-a-vis my team's velocity and impact. Yeah.
And so just to unpack that a little bit, some part of that was that you're able to do some individual contributor-like tasks that would have been hard to find time to do before because you can accelerate it. And the other is in sort of summarizing or analyzing some of their contributions, like their diffs, et cetera?
Yeah, I think that the underlying theme is that like the engineering systems are very, very complex and they're very hard to understand. And then like changing those systems, especially if it's like a very distant point you want to get to and how you're going to get there is also very complex and hard to understand. And as a people manager, you got 12 people you got to meet with, you got like your boss who's mad at you, you got your stakeholders mad at you, maybe you don't have time to understand that full amount of complexity. And so like I've found LLMs to be able to simplify that complexity for me in such a way that not only can I understand what people are doing, I can like perturb it myself and get more firsthand experience. So that's been incredibly useful.
Yeah, I want to emphasize on that because I see a lot of potential. I can see potential for data science, for AI, for data science. So when you think about like, I work on experimentation. Well, people work on analytics and algorithm, but I can tell you right away is that like the experimentation review process itself is actually all like, we go from like hypothesis generation, which AI can help. Then we run the experiment. Now we come into the time in which we review the experiment. It's actually a pretty intensive process. Usually you cannot look at 3 metrics, which is your primary metric, and you say ship or no ship. Usually you dig in, you figure out like, okay, what goes underneath the hood. You do a bunch of slicing and dicing. You run like another statistical analysis. I would see a lot of that can be actually generated, like the first rough path can be generated by AI. We can have like some kind of AI agent to actually think about like, okay, like I see DAU going up. Can you figure out like how is the app performance going? Can you figure out like how many users hit this trigger point? Can you figure out like what is like how many engagement? What is the time span look like? What is the hypothesis that we follow up on? So I mean like this whole like basically DS can spend like hours and hours for like one experiment to figure out what is the product inside. I'm not saying that we like AI can replace data scientists, but let's just say you're actually carving like, I don't know, David, then you know like AI can take the first pass to actually get you like a rough sketch of what is going on. Well, I'm not doing David, I'm not carving David, I'm doing Play-Doh, but still like, it's like the first pass can actually be done on like agentic AI.
Maybe to add a little bit, so we have a lot of internal use cases, especially because games are kind of hard to understand. So it's like, can you read all these game descriptions? And can you like look at these screenshots and figure out what's going on? And like maybe build some variables that I can use to slice, things like that. But we also have these external use cases where, so we already have an AI assistant for creators to look at their stats, right? So if you create a game on Roblox, you can see your retention, you can see a bunch of metrics. And for some people are not familiar with data. So we already have an AI assistant to help them make sense of the data. And it's a lot of dashboards. We just started experimentation for a creator. So now there's already a lot of people running experiments. And so pretty soon, I mean, you know.
I think just to emphasize that this is pretty cool that basically people who are creating games and, you know, just anybody might then run an experiment with their whole game design.
That's right. And we make it as easy as possible so that, you know, even if you're a small creator, you've never really, you know, and a lot of our creators, I mean, you know, picture like a 16-year-old who's really motivated. Like it's not always like a professional studio. It could just be someone with a middle-of-the-road computer who's just been spending a lot of hours because they really love gaming, right? And now essentially they're going to have these assistants. They already have an assistant for analytics, and they're going to have. I mean, I'm not saying we're doing that, but it would be a likely step. Now that we've done creative experimentation, is to actually help them generate hypotheses, analyze experiments, get results. So yeah, pretty exciting, I think, for democratization of A/B testing.
I think you want to add something, Bill?
Yeah, so what I'm really excited about is not something that's already here, but what's on the horizon. And specifically, what I'm really excited about is synthetic A/B testing. So not actually A/B testing on real people, but using LLMs as agents that can actually adopt the personas of your actual users. So you basically train archetypes so that an LLM can accurately assess out-of-sample behavior of your users. This is not science fiction. There are actually researchers in this institution who are working on this, and then there are also people in industry who are working on this. And this has, in my mind, it's going to be, if this works, and I hope it does, is going to be a game changer for the industry because we've talked a lot about hypothesis generation, but if we look at the numbers, I think the median success rate of A/B tests is around 50% across the industry. So we're not very good. It's basically you're tossing a coin. We're trying to get better, but still there's a lot of failure. And in a lot of those failures, there's actually guardrail failures in the sense that you're actually doing harm. You're not just not succeeding, you're actually doing harm. And when you do harm, you're exposing your users to a bad experience. You can avoid that by actually testing this thing on synthetic users and then launching something that only works, or at least use it as a prototyping tool. And then, as a second step, test it on actual humans. So I'm super excited about it. It solves this problem, and it also solves the speed problem. You can run 100 experiments overnight against synthetic users. You just need the compute to do that. Obviously, there's a cost, but you do the analysis, you do the ROI.
Yeah, I think that's a really profound and amazing answer. And I think it answers the question from, I believe, maybe Lihua was his name, the person who asked, what is the next online experimentation for the next 10 years? I think it's simulation, prediction, offline experimentation will become very good. We've already seen in my team that like our ability leveraging LLMs to run very accurate offline simulation is like incomparable to where it was even 6 months ago. And we can like design whole roadmaps, simulate them, and decide what to do without even touching anything online. And I think that's the phenomenal area to work in if you're looking for somewhere to work.
Plus, what I'd say gaming is probably going to follow a similar path. I mean, I'm going to date myself, but if you're playing Quake in the 90s, you're probably already playing against a computer, right? So the idea of like kind of AIs in the game that are doing things is something that's always been there. And so of course, it's a very natural kind of follow-up to try and see if we can A/B test on it.
Yeah. Yep. I think we've got another question over here. Yeah.
Oh yeah, thanks to the speakers. My question initially was actually overlap with yours, but I'll ask the other side of the question. So to me, like experimentation platform, like especially toward mature products, is intriguing in the sense it has to be both delicate and rigorous. And these days, people use AI for everything and truly boost a lot of productivity. But I just wanted to ask, like, from your perspective, what are some areas, like when people use AI to do experiments, these requires a lot more caution or checks, or like people just need to be more careful, like for junior data scientists?
Yeah, so I guess some of the possible risks of kind of accelerated AI adoption in the experimentation space.
I've seen a couple of AI-generated metrics where people like type to Gemini prompt, and Gemini say, oh, just use this like complicated entropy metric or whatever, and people just using it without really thinking, and then things kind of like not really working quite as well. So I think that's been a use case for sure. And of course there's this, we're at an imbalance, which is like, it's very easy to generate a very complicated mathematical formula and use it. It's very hard to check it if you're a human trying to make sense of it. And so there's a bit of an arms race a little bit where it becomes really easy to be very confidently wrong.
Yes.
And so, yeah, I don't know that I have a solution for this, but I've definitely seen it.
Yeah, no, especially something like that. I mean, part of the appeal, and I think part of how A/B testing has become so common is really how simple the basic version of it is. Like we spend a lot of time talking about the complications, et cetera, but the simple version is like really easy to explain. And you start dropping in all kinds of AI-generated code to create other metrics or analysis strategies, and you're losing a lot of that explainability and transparency. Any other thoughts on these risks from AI and experimentation?
I think like on the AI side, I think AI is very helpful and it's actually accelerate the product development really fast. But at the same time, you develop a lot of product idea. There probably is something, you probably increase the number of incidents of like your product actually doing harm. So I think like having like an experimentation platform, keep everyone honest, like figure out like what is the metric that people are actually talking about. Can we agree on the metric definition? Can we agree on like what is the launch criteria? And then people can launch, but then we can actually have a lot of guardrail. We can think about like, okay, we have what is the criteria for discontinue the experiment early? What is like our tolerance of risk at this point is actually very important in the age of AI-assisted product development.
I think
also like AI testing. You can develop your product with AI, but maybe you can actually test it with AI to actually figure out like in simulation what is going to happen in real life. I think that is something to help de-risk the product development.
Yeah, if you have a sandbox where you can just let the AI loose to do experiments synthetically, there's no risk except for compute, obviously.
So one topic, since we're almost out of time, one topic we really wanted to get to is thinking about a culture of experimentation. So in some ways, I think a lot of people would, in the companies you're all in, there is a rich culture of experimentation to some degree, compared with what the status quo was 15 years ago, right, where that was very not distributed. But so to some degree, we're all kind of advocates of experimentation practice, I mean, as a means to an end, but that often it is a good means to adopt. What are some of the ways that you've seen differences in diffusion of experimentation across different parts of an org, where some parts of your company are experimenting a lot more than others? Is that just because it's harder or easier in different areas, or are there often still kind of cultural gaps or gaps in the adoption of these innovations?
I would say, like, I mean, the one thing that dominates, I mean, there's huge cultural differences even across different, like, you know, parts of a company. But the one thing that still dominates in my mind is cost, basically, and complexity of experimentation, which is it can still be pretty difficult to set up an experiment. Like, it's so the more we can do to make it super easy and almost automatic, where to the point where you just tell the engineer, like, you know, I think the place to start is essentially like a stage rollout and kind of start there and show value there in terms of like, I'm going to work with the CI/CD and the release management to make sure that features are just automatically A/B tested on their way out. That's going to yield some surprises. It's going to lead people to question a little bit their intuition. And I think that's a kind of good gateway drug culturally to get people to accept experimentation. But I would say, like, in my mind, it's still very much like cost and complexity. It needs to be easy and cheap, and it's not always.
Yeah, I think that's a great answer. I think just the only thing I'd add to it being easy and cheap is that it should be easy, cheap, and fun, which is like actually like people who are building things should or mostly do feel some great ownership over what they're doing. And like experimentation, because of its evaluatory component, can feel like a judgment beyond your control, right? And many teams don't want to be evaluated by this thing they don't understand beyond their control. And so like empowering, and to the person's point over here, empowering the person who's building the product to run their own random experiments, to like design, to have like hands-on experience and do as fast and high of a throughput as possible, really helps build the culture from the grounds up. I think relying on like a tops-down mandate to run holdbacks, to run an experiment before every ship, results in a very brittle, fragile culture that leads to over-optimization, that leads to like these like sort of like pitfalls that I believe Bilal was mentioning earlier.
Mm-hmm. And also to Guillaume's point, is actually you go around, socialize experiment results, talking about like unexpected things that you observe in those like stylized experiments actually really have like to drive the point home, especially with the leadership, who is actually a little bit like high level in terms of business, and they can actually understand the value of experimentation. Some come very naturally. Some leadership, like experimentation, doesn't feel natural, but it's actually the job of the data scientist to drive the point home. And you can do it through example, you can do it through like different like workshop, but at the end of the day, it's kind of like responsibility of the data scientist.
This is where sometimes a PhD education can hurt you a little bit.
Exactly.
In a sense, because I think there's this ethos of like, oh, I'm going to be super careful. I'm going to see what the data says. I'm going to really be a scientist and be super kind of really rigorous about everything. And sometimes people just value conviction, right? And so value just like, hey, I think this is going to work, and we'll put it to test with data. But I've seen also this failure mode of just trying to be so scientific, so rigorous, so careful, as if we're trying to get into a journal, and as a result, not inspiring confidence.
I have an engineer who doesn't have any background in statistics, but I use them as a smell test. If there is something I cannot explain to them, it means that like I fail. It's like we can get like overly academic, we can get like into the weed, we can get too much into detail, but what is the message that we want to drive home? That's when we actually have to talk in like a business context, like a kind of like consultant's hat.
Cool. I think that may be a good place for us to wrap up. Let's thank our panelists.